Okay, so in question 15, it's asking us to find the velocity at the bottom of the inclined plane. When we have the values of 3 meters and this theta equals 30 degrees, this one is actually a little easier because we could just go ahead and use the formula V2 minus V initial squared, which would be equal to A times delta x. So in order to go ahead and get our acceleration that we can use, we use A equals gravity times sine theta equals 30 degrees, which would be equivalent to 10 times 1 half, sorry. And you can go ahead and now we have our values, which we can plug into our formula and get that 5.5 meters per second for our velocity after we square root it. So for part B, it's going to be a little harder because we're going to have to find the velocity at the bottom of the inclined plane. But now we have n, so some parts missing, so we have to find them. So we can go ahead and start off by getting a look at our x and y planes. So for x, we're going to see that we're going to use the equation f of x equals mg times sine of theta minus our force friction. And for our y, we're going to use Fy equals mg cosine theta minus r normal, which would be equivalent to 0. For our normal, we can go ahead and say that it's going to be equal m of g10 cosine for theta. Therefore, we know that our m is going to be 0.3, and we know that our normal could go ahead and be RMG times cosine of theta, so we multiply both of them. In the months after we simplify, we're going to end up having to divide, and then to get our acceleration for our x1, our x-plane, we need to plug in our values, and we end up getting a acceleration of 2.40. And now that we have our acceleration, we can go ahead and plug it into our initial formula. We can go ahead and get our velocity, and we know that our v2 is going to be the minus initial squared equals 2 times 2.4, which is our acceleration, times delta x, which is going to basically be at 3. So we get our values at v equals the square root of 2 times 2.4 times 3, which once you put it into a calculator, it gives you the velocity of 3.79 meters per second for our part B. And that would be all for this question. Thank you.